Okay, we're going to work on the Honors Physics CAPM Practice Problem 3 about a drag racer. Since we're looking to draw the graphs here, we're going to use graphical problem solving along the way. Okay. Alright, first we'll draw some axes. When we draw these graphs, in terms of labeling, it's easiest if we just we can draw the shapes and then kind of label the important points instead of taking the rest of your life to scale everything perfectly. That can be a real pain. Okay, so our drag racer is going to begin at rest. That means the initial velocity is 0 and accelerate to 140 meters per second within 2.1 seconds. So I'm going to label those values there. And then the drag racer maintains that speed through the finish line, so it's going to go for some unknown time, delta t, and I'm going to go ahead and label that because I don't know what it is. If I'm going to draw the position graph, I can draw the shape first and then fill in some values. So you could start this at anywhere. I'm just going to start it at 0. Because the initial velocity is 0, I know I have to have a flat tangent line at the beginning. Okay, and then the slope should increase because the velocity is increasing. And that'll happen up until I get to this point, at which point I go into CVPM with the same velocity that I had at that moment. So it should be a smooth transition into CVPM there. Okay, and again, that's my 2.1 seconds, and I don't know when that is. What I do know here is that this is 400 meters. For acceleration, I'm gonna just find the slope of that segment. The slope of this segment is 0. So we go final velocity 140 meters per second, initial velocity of 0, and that took 2.1 seconds. So this acceleration will be 66.7 meters per second. And it's constant, and then it's constant again while it's 0. Okay, so we're pretty much done with the acceleration graph. The real show now is with the position and velocity graphs. So what I know is that this whole area, I know this is my delta x total, which is 400 meters. And that equals this big area here. So you can break it up into a triangle and a rectangle if you like. If I'm going to do that, I'm going to call this velocity v. And what I want is the height of this triangle, which is v, times a half, times that initial delta t, maybe we'll call it delta t1. Okay, so that one we know. Plus the area of this rectangle, which is v tall, and delta t wide, which we don't know. Okay, we do know the delta x total. We know the v. We know the delta t1. We know the v, so we can solve for the delta t here pretty easily. That's one of the things we're looking for, so I will solve for that. Okay, you could break that into 2 bits if you wanted, canceling the v out on that term, but then it would still be in this term. It's going to look about like this anyway. Okay, so this will take a further 1.81 seconds after you plug in the numbers and check the units, make sure they work out. That will put us at 3.91 seconds there. Okay, so I've solved for that. The only thing that I don't know now is what this position is, and I can get that pretty easily just by looking at this little bit. So my delta x1 is 1/2 v delta t1. That's my 140 meters per second and my 2.1 seconds. And that's going to be about 147 meters. So that'll give me my last bit. Didn't even need to do any algebra there. All right, there we are.